Good afternoon. Today's topic is, the subject name is Engineering Thermodynamics. And I've already taken few classes in this field of engineering mechanics. Today's discussion is on isolated system. You already know that three types of systems are there: closed system, open system, and isolated system. And in the previous class, thermal flask was used as an example of isolated system. But you should keep in your mind that thermal flask can be considered as an isolated system only for a short interval of time, not for a long time. If you keep hot tea or hot milk or any other hot liquid inside the thermos flask for a long time, then you will observe that the temperature goes on decreasing with time. If the same hot fluid is kept in the open atmosphere, the temperature will go down with a rapid speed. But in case of thermos flask, the same thing will happen. Temperature will go down, but with not rapid speed. It will be slower comparatively. Okay. So thermos flasks are used to keep the hot fluid to be hot for a long interval of time. For a long interval of time. Okay. Not forever. So suppose you have taken one thermos flask, you have put some hot tea inside the thermos flask, and now close the lid of the thermos flask. And if you observe, take a thermometer, somehow you arrange to measure the temperature of the tea. Say initially the temperature of the tea is 80 degree Celsius, 80 degree, 80, okay, 80 degree Celsius initially, when you are starting your experiment. And just after 1 minute of time, if you use the same thermometer to measure the temperature of the tea inside the thermos flask, just after 1 minute of time, then I think you will notice that there is almost no change of temperature. It remains almost 80 degrees Celsius. Again after 1 minute of time, again you will find that the temperature remains constant at 80 degrees Celsius. So you have done your experiment, you have conducted your experiment only for 2 minutes of time, and if you conclude that thermos flask is an isolated system, you know that isolated system means there is no energy transfer as well as there is no mass transfer. So in this case there is no question of mass transfer. The lid of the thermos flask is closed, so there is no chance of mass transfer, but there is chance of energy transfer. So we are testing whether there is energy transfer or not present in this case. So just after 2 minutes of experimentation, if you conclude that no energy is being transferred to the surrounding atmosphere, so then you will be wrong. You do the experiment for long time. Now we wait for 1 hour, 60 minutes, okay? And then again measure the temperature of the same tea. I think in this case you will get a lower temperature, lower than 80 degrees Celsius. Maybe it's 78 degrees Celsius or 79 degrees Celsius. I am just giving you an example. You know that with time, if you have already used thermoflask, then you know that. With time, temperature of the liquid inside the thermoflask decreases, but with a slower motion. Okay? So it is written in the book that example of isolated system is thermoflask. And if you think that, oh, it is thermoflask, that means there is no energy transfer, then you will be wrong. For a short interval of time, thermoflask can be considered as an isolated system, but for not long period. Okay? Why these concepts are used? Open system, closed system, isolated system, etc. Why? Just to simplify our scientific or the engineering problems. Just to simplify. Otherwise, in all the cases, we can consider the actual conditions. The equations available to solve problems on fluids or problems on thermodynamics. If before starting the calculation, you make some assumptions, then the calculations will be simplified. The length of the equations will be reduced. So it will be easier to solve the given problem, as well as time required to solve the problem will be less. Okay? So say you are interested in making calculations for a thermos flask. So if you know that the time which is allowed for the calculation, for the given calculation is only 5 minutes, not more than that, only 5 minutes, then you simply assume before starting your calculation that there is no energy transfer. There is no energy transfer to or from the system. Your system is your thermos flask. There is no energy transfer. The wall of the thermos flask prevent energy transfer. The wall of the thermos flask prevents energy transfer. You just keep in your mind this thing, so your mathematics will be simplified. The mathematical equations will be reduced. The length of the mathematical equations will be reduced. So calculation will be easier. Okay. So whenever you are studying engineering or any subjects of science, in all the cases, keep in your mind the limitations of the equations, limitations of the physical situations, etc. Nothing is rigid in nature. Nothing is absolute. Nothing is absolute. Okay? Okay, thank you. In the next class, I'll start a new topic on the same subject, engineering thermodynamics. Have a good day.